To most astronomers, the universe began with the Big Bang about 14 billion years ago. Before the Big Bang occurred, the universe was inside a bubble, smaller than a pinhead. It suddenly exploded. The universe as we know it was born. Time, space, and all matter began. In under a second, the universe grew from smaller than a pinhead to larger than a galaxy, which is still expanding today. As the universe expanded and cooled, the energy changed into particles of matter and antimatter. These two opposite types of particles destroyed each other, but some matter survived. More stable particles called protons and neutrons started to form when the universe was just 1 second old. After the next 3 minutes passed, the universe's temperature dropped below 1 million degrees Celsius. This meant it was cold enough for the protons and neutrons to come together, which formed hydrogen and helium nuclei. If the universe was expanding with age, it must have been smaller in the past. This suggests that if time went backwards, all space would shrink to a single point. Very early in its history, the universe was very hot. As it grew, the heat left behind glow that filled the entire universe. The Big Bang Theory not only predicts that this glow should exist, but that it should be visible as microwaves. The cosmic microwave background is very good evidence that the Big Bang Theory is correct. As the universe cooled down and expanded, some of the elements that we see today were created. The Big Bang Theory predicts how much of each element should have been made in the early universe. All stars begin the same. Before a star is born, it is known as a nebula. A nebula is a cloud of dust which contains hydrogen, helium, and plasma. The first stage of a star's life is called the protostar. It is a ball of gas and dust that is pulled together by force. Nuclear fusion begins when the gas cloud becomes hotter and denser. The life cycle depends on the starting mass. The small mass star's cycle begins with the protostar, main sequence, white dwarf, and black dwarf. The medium mass star cycle begins with the protostar, main sequence, red giant, white dwarf, and black dwarf. The large mass star cycle begins with the protostar, main sequence, supergiant, and the supernova, which can turn into a neutron star or a black hole. The main sequence stage of a star is also known as its middle age. The main sequence is the longest stage. Hydrogen fuses into helium, which creates enormous amounts of energy. The size of the star does not change much. All stars go through a main sequence stage. The red giant stage only happens for medium mass stars. It occurs when stars begin running out of hydrogen. The star will start cooling down and expanding at the same time. The end of the red giant stage happens when the atmosphere of the star becomes so spread out it slowly disappears. This stage is called planetary nebula. A white dwarf is a small hot star that is the leftover centre of an older star. They can shine for billions of years before they extinguish. The supergiant stage only happens for large mass stars. It occurs when the star begins running out of hydrogen. It starts cooling and expanding at the same time. It sounds just like a red giant, but the big difference is the size and brightness. Supergiants are up to 1 million times brighter than the Sun. A supernova is a gigantic explosion in which a massive star collapses. It occurs after a massive star uses up its fuel source. A neutron star is a star that has collapsed to the point at which all particles are neutrons. A neutron star that spins and sends out beams of radiation is called a pulsar. A black hole is an object that is so massive that light cannot escape its gravity. Astronomers use X-ray telescopes to detect black holes in our galaxy. Milky Way is the galaxy that contains our solar system. The Milky Way is shaped like a whirlpool that rotates every 200 million years. Our galaxy is a typical barred spiral and it is about 100,000 light years across. Our solar system includes 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. Earth is the third planet from the Sun and is home to 8.74 million species. Earth was formed around 4.5 billion years ago. The Earth's shape is a sphere, flattened along the axis from pole to pole. The Earth also has geologic layers, which are the crust, upper mantle, outer core and the inner core. The Moon, also known as Luna in Latin, is Earth's only natural satellite. It is the second brightest visible object in the sky other than the Sun. The Moon has very little gravity compared to Earth. The Moon completes a full orbit around once every 27.3 days. There are 9 phases of the Moon: the new Moon, waxing crescent, first quarter, waxing gibbous, full Moon, waning gibbous, last quarter, waning crescent and the new Moon. For more than 150 years, scientists have collected lots of evidence to support evolution. Evolution is the slow process that changes animals and plants over a period of time. The story of human evolution began in Africa about 6 million years ago, and it describes the very long process that our ancestors went through to ultimately become modern humans. This process has been uncovered by studying fossils and understanding the underlying theory of evolution, and while new fossils are uncovered every decade revealing new chapters, scientists agree about the basic story. After the Big Bang, the Earth was full of rivers of lava. 800 million years later, the planet cooled and rain began to fall, creating rivers, lakes and oceans. Still at this stage there was no life. The Earth's atmosphere now contained a mix of very poisonous gases including carbon monoxide, carbon dioxide, nitrogen, hydrogen sulfide, methane and cyanide. Breathing this air will cause death to most life forms as we know them. It is believed that people came to be through evolution. It is believed that the first cells were made in tidal pools full of amino acids, proteins, lipids, and other basic components that are commonly found in life forms today. Over millions of years' time, food supplies began to diminish. As a result, new types of cells had to form. These cells were called producers. Producers evolved the ability to actually create their own food, using the chemicals around them and the energy from the sun or from the heat found in the earth. These producers would be ancestors to the plants. From very simple cells to multicellular human beings, life had a long way to go. Some very important advances helped to make the life we know today. The cells that used oxygen advanced dramatically, considering there was very little oxygen on Earth to begin with. However, these first cells continued on living by releasing their own oxygen into the atmosphere. Over a very long period of time, the atmosphere turned from deadly gases to the fairly clean air we have today.